Dear student, now start chapter 3 concerning image basic. In this chapter we'll go quickly because it's general information about image, types of image, definition of colors, and different types of color systems. And information about the eyes and some other definitions. So we'll go quickly in this slide. So image formation, as you know, we have a light that is emitted by any light sources, sun, LED, lamps, etc. So the light is reflected from the image. This is the sun. The light is reflected from the trees, and the reflected light is sensed by the eye or camera. So in general, the eye see the reflection or the reflected lights from the object. So the real image is projected on the retina. This is the retina. The lens, this is the position of the lens, is to adjust its power to produce the image on the retina for object at different distances. So the object or the objective of lens is to adjust its power according to the position of the object, if the object is near us or it's far for us. So the lens adjusts the power. The center of the image falls on the fovea. This is the fovea. This is where the image of the object fall on it. And this region has the greatest density of light receptors. In the eye, we have what we call light receptors. The light receptors receive the light and send the image by the neurons to the brain to interpret the image. The pupil have variable opening due to chemical adaptation, which allow the eye to detect large lengths of light intensity. So the objective of pupil is to adjust the opening the opening and the closure according to the light intensity. If the light is strong or if the light is low. So we have two control system. The first, according to lens, to adjust the object if it is far or if it's near us, in order to allow the image of the object to fall on the fovea. And the other is to adjust the opening of pupil, is to adjust it according to chemical adaptation, according to the light intensity. So the visible light spectrum, we talked about it in the previous slide. The human just see the visible light spectrum from the 400 nanometers till 700 nanometers between the ultraviolet and the infrared. We cannot see ultraviolet colors and we cannot see the infrared. And this is the colors: violet, blue, green, yellow, orange, and red. And we can see these colors if you use a glass prism. So the retina contains, as we said, photoreceptors. And these receptors absorb photons or the reflected light and transmit chemical signal to the brain, where the brain interprets these photons of the image of the object in order to be interpreted and to be recognized by human as this is tree, this is car, this is red color, this is blue color, etc. So for the receptors, there are two types: rods and cones. Rods are night vision receptors, no color dependency. So rods, if you want to say that, we can see the white and the black image without color. Just we see the object whenever it's light. We have 10 million rods responsible for luminance. 10 million. You can imagine that you have in your eye 10 million receptors of rods. Cones, in contrast, are color sensitivity. Color sensibility, it means that I can differentiate between the different colors: red, green, blue, orange, violets, etc. See, so the cones need higher level of light intensity, because when the intensity of light is increased, I can differentiate or recognize more colors. We have 6 million cones that measure the colors. So in the brain, in the retina, we have 16 million receptors. 60 million photoreceptors. 10 million for rods, just we detect the image without whenever is its color, and 6 million that its role to differentiate between colors. From the retina, we have 1 million nerve fibers that carry the information to the brain. So this is a nerve. We have 1 million nerves on the fibers that goes to the nerves to interpret and recognize the image. This is the retina that we talk about. This is the lens that its role to adjust the view of object far or near the human. And this is a pupil that can close or open according to the luminosity. And this is here the region of fovea, where we have the photoreceptors. Of course, the optic nerve goes to the brain. So retina sensibility, there are 3 types of photopigment in the cones. The cones, as we said, is responsible of differentiating the colors. And we have 6 million cones that measure the colors. Now, we don't have one type of cones. We have 3 types of cones. One is blue, that have maximum sensitivity at 430 nanometer, which is the maximum sensitivity. Green with maximum sensitivity at 530 nanometers, and red with maximum sensitivity 560 nanometers. These are the shape of rod and cone. Rod, we have 10 million. Just differentiate the object, see the object whenever it's color, and this is a cone. We have 3 types of cones: red, green, and blue. Okay, this is the light that comes. This is the cones, this pigment cells, these rods, these are the photoreceptors, these are the synapses to the nerve fibers. Okay, so retina sensibility, eye is not sensible in the same way for all colors. The sensibility of the eye to the red is not the same for the blue, not the same for the orange, not the same for the violet, not the same for the yellow, etc. In general, it's more sensible on the green color. So for that, when we go in the nature and we look up to the trees, greens, forest, etc. in the view, we have to we feel good because our eye is not it's have a great sensibility on the green colors, and we see just the green color. Okay, so we have relaxing. The eye is relaxed. So for that, we seem good when we look on the nature for the green color. Okay, so this is the three colors: 430 nanometers, 540 nanometer, and 560 nanometers. Okay, now for the percentage of cones, we have, as we said, three types of cone: red, the green, and the blue. We have 64% for red, 32% for green, and 4% for blue. And if we look in the distribution, at the retina center, the dense distribution of cones, and there is no rods. This is the retina. At the center, we only have cones. We don't have rods. Because at the center of the image, we identify the colors of the objects. Periphery, this is a periphery. We have many rods, but few cones. We have rods here, but the number of cones is low. At the center of retina, we have green cones surrounded by red cones. Here, in the center, we have green and red. And at the peripheral, we have blue cones. We don't have any blue cones at the center. So to summarize, at the center of retina, we have red and green cones. At the peripheral, we have blue cones and we have rods at the peripheral. And remember that cones is responsible for the colors, rods is independent of the color. Okay, now for the color space. Theoretical, we can create any secondary colors using three primary colors: RGB, red, green, blue. For example, if we add green and red, we obtain the yellow. If we add red and the blue, we obtain the magenta. If we obtain green and the blue, we obtain the cyan. If we add red and the green and the blue, we obtain the red color or the white color. So this is what you call the color space. And we have subtractive color. Subtractive color is when we used in painting. When we use mixed paints, we use subtractive colors, CMY. Cyan, this is the blue color, magenta, and yellow. This is used in mixing paint to create wide range of colors. So if we mixed yellow and magenta, we obtain red. If we mixed yellow and cyan, we obtain green. And if we mixed cyan and magenta, we obtain blue. If we mixed the three colors, yellow, magenta, and cyan, we obtain the dark or the black color. And this color is used in printers to create all the colors that we need in color printing machine. So what is the idea of, or the history of RGB color? RGB color matching is invented by Hermann Grassmann in 1853. So we have three lamps with spectral distribution RGB. We have red color, green, and blue color. These are three lamps. And we have the factors RGB. It means the color impression or the intensity of the light. How the light is intense, the intensity of the color. So we can change the intensity of the blue color, green color, and red color. And what we call the intensity, it means we have what we call potentiometers or similar device that aims to intensify or to lower the intensity of the blue color, green color, and red color. Okay, So another lamp, fourth lamps, is put on the other side. So Hermann Grassmann changed the intensity of red, blue, and green color until we obtain the same color that we have at the other side. And for that, for example, the yellow, it's a combination of red, green, blue with different intensity. So to obtain the blue-green color, this is the blue-green color, we use intensity 7 for red, 32 for green, and 39 for blue. While for vibrant blue-green, Hermann Grassmann have seen that to obtain this color, we have to use 42 for green as weight, 91 for blue, and transform the red color to the left size to match the two colors. So to obtain this color, we have to transform this color to the left size with the intensity of 38 and to put 42 and 91 for green and blue to obtain the vibrant blue-green. So it's like we have a negative color because when we put the red to the left size, it takes the sign minus. So for that, we have minus 38 for red, plus 42 for green, plus 91 for blue. So what's mean by negative color? So after that, we have what you call the Commission Internationale de l'Éclairage. It's an association, international association, to put standards for éclairage or lighting. And in this commission, we replace the lamp by 3 monochromatic sources as LEDs, for example. The red with 500 nanometers, green 546.1 nanometers, and the blue 435.8 nanometers. But we still have negative colors. So how to avoid the negative colors? For that, we make a transformation, axis transformation from the RGB, the standard RGB, and we introduce XYZ system. And we change the coordinate from RGB to XY system by defining a new 3 non-orthogonal base vectors. In a case that we don't have any negative color. And XYZ is just any simple transformation. X equal X over X plus YZ, Y equal Y over X plus YZ, and Z over X plus Y plus Z. And this is planar representation of colors in XY, red to green, plan. Just its objective to not have a negative colors to obtain the other colors. In this case, in the system XYZ, we has 62% green, 25% red, and 13% blue. This is what we call CII chromaticity diagram. If we want to compare RGB to CMY system, it's a straightforward systems. And CMY is suited for hardware implementation, while RGB matches human eye perspective abilities. And we can transform RGB to CMY and CMY to RGB by using this transformation. So this is our 2 complement colors. We also have what we call HSV system. HSV system, it's represented by hue for H, it means value, saturation, and value. Hue describes pure color or dominant wavelengths. It means what is the pure length, the pure color which is dominant in this color. It's measured on nanometers. Saturation measure the purity of color or degree of white light mixed to it. It means that if we have the red colors with special nanometers, how this colors is far from the standard nanometers. And we have the value, it based on the brightness or luminance of intensity of the color. If the color is fade or the intensity of color is high. يعني الcolor باهت ولا فائع. هذه it means about value. الساتوريشن بتحدد لي نسبة الأحمر اللي موجود. إذا عم نحكي نحن عن الكالر أحمر، قديش نسبة الأحمر؟ هل هالأحمر هو أحمر فعلي ولا أحمر فاتح أو غامق؟ بمعنى الباهت ولا اللون النقي؟ قديش نسبة النقاوة الأحمر بالكالر؟ طبعا إذا بنفتح edit colors بنفوت على البينتينج، يعني نفتح بروجرام البينت وبنشوف الكالرز، رح نلاقي هون RGB اي كالر بدنا اياه بنختاره، بيعطيني هون RGB تبعه ريد جرين بلو، بيعطيني HSL طبعا luminosity او HSV الفاليوز اثنيناتهم نفس التعبير. فاذا في انا انقي كالر حسب RGB تبعه او حسب HSV. طيب نجي للديجيتال ايمج. As we said, digital image is two-dimensional image. هو عبارة عن table or matrix في بقلبه discrete values. The value, the position of the pixel in the matrix بتحدد the position of the pixel in the image. هاي بنسميها نحن spatial information or layout. اثنين عندي intensity or color information وهي value of the pixel of the value of the pixel. قديش قيمتها. So layout أو الشكل الخارجي للصورة is characterized by IMN. قديش قيمة الMN which is the response of sensor or value of interest. هلا الMN هي عبارة عن matrix مثل ما قلنا. It's a Cartesian coordinate that represent the position of the pixel. فإذا هو موجود على الM row والN columns. والقيمة تبعه بتحدد قوة الكالر. طبعا عندنا نحن مش بس 2D، ممكن يكون عندي 3D ساعتها بكون عم نحكي عن فوكسل، ممكن يكون عندي 4D يعني ممكن يكون عندي الصورة 4D dimension ساعتها بكون في تايم وعندي فيديو. Image contains one or more color channels that define intensity or color at a specific position IMN. So the value of IMN بتحدد لي قيمة الكالر. هلا طبعا كل بيكسل location يعني IMN عندها one numerical value لأنه عندي just one color. هلا بالجراي سكيل value for example قيمة البيكسل IMN بتتحدد قديش قيمتها. إذا كنت أنا عم بشتغل بالرانج اوف جراي ليفل، يعني نحن بنسميها الجراي ليفل يعني الرمادي، بيكون عندي different intensity. for example الجراي ليفل العادي هو 256 ليفل، البلاك هو الزيرو الاسود، الابيض هو الماكسيموم يعني 255 255، والكالرز بتوزعوا between 0 and 255. اذا كان النمبرز قريبه من الزيرو معناتها اللون غامق كثير، يعني عم نحكي عن الرمادي القريبه من الاسود. and if the color is beside the maximum values لنقول 220 230 اللي هن near 255 بيكون الكالرز قريبه من الابيض الرمادي الفاتح. طبعا الانسان بيقدر بس يتعرف على 40 shades of gray، 40 يميز كانسان كالعين الانسان بتميز 40 level of gray. بينما نحن بالكمبيوترايز سيستم اذا عم نستخدم ال 8 بت بقدر يميز 255 او 256 level of gray. يعني انا بقدر ميز قد العين الزياده عنها 216 مره. هلا الكولر ماب RGB and HSV البيكسل لوكيشن ما بتكون مؤلفة من 1 فاليو، بتكون مؤلفة من 3 فاليو. وحدة للريد، وحدة للجرين، وحدة للبلو. يعني أنا عندي IMN إذا أخذنا البوزيشن لنقول 1 1 بالجراي ليفل I11 بتساوي 20. 20 معناتها قريبة من الزيرو، معناتها هذا لون رمادي غامق. بينما إذا كنت عم بشتغل أنا بالار جي بي أو الاتش اس في، الاي 11 رح يكون عندها 3 values. I11 for green for red، I11 for green، و I11 for blue. ونفس الشيء إذا كنت عم بشتغل بالاتش اس في سيستم. وبالتالي ما بيكون عندي ماتريكس وحدة لأعرف عن الصورة، بصير عندي 3 ماتريسز ورا بعضهم بخيال بعضهم. وحده للريد، وحده للجرين، وحده للبلو، اذا كنا عم نشتغل بالتريبلت كلورار ماب. بينما اذا عم نشتغل بالجراي سكيل ليفل الايمج از ريبريزنتد باي 1 ماتريكس. بينما بالكولر ماب تريبلت بكون عم بشتغل انا على 3 ماتريسز ورا بعضهم خلف بعضهم، كل وحده ريبريزنت كالرز، ونحن بس ندمج الار جي بي بيطلع معنا الكالر اللي عم ندور عليه. So true color image تعطيني natural color orientation، يعني بحس حال الكالر اللي انا عم بشوفها نفس الكالر اللي بالطبيعه. So it appears the same for human observing. فلما اكون انا عم بتطلع على شجره خضراء بشوف نفس اللون الاخضر بالصوره، لكن نحن بنعرف في different levels of green، مش كل اللون الاخضر عندهم نفس اللون، كله بنسميه الاخضر بس في الاخضر الفاتح للغامق اكسترا. وهذا بودينا للفالس كولر ايمج that depicts an object in color different from a human observer. فإذا أنا بشوف كالر بعكس ما هو موجود، مختلف عن اللون اللي بالطبيعة. شو السبب؟ ممكن يكون في ألوان outside visual spectrum، وبالتالي الفالس كولرز ممكن يعطيني false detection للفيتشرز. رح نفرجيكم نحن مجموعة صور. طبعا لما اطلع أنا على الحقل بالطبيعة، إذا عم بطلع أنا على بستان مزروع شيء، ولما بطلع أنا هون ب different colors، اوكي، هون عم بشوف أنا false color. الهدف منه إنه ميز أشياء مش قايس شوفها بالعين المجردة. مثلا left image هاي الصورة shows vegetation density، وين في زراعة وين ما عندي زراعة. مثلا هون عندي density، هون عندي density مزروعة كثير، هون الأصفر مزروعة خفيفة. الميدج ايمج تعطيني المي. الجرين بلو، الجرين والبلو اللي انتم شايفينهم هون والبلو هون، جرين والبلو، بتعني انه انا عم بشتغل على وات سويل، يعني التربة رطبة. بينما الاحمر بتعني انه التربة ناشفة. فهيك انا بقدر ميز وين عندي رطوبة بالتربة وين ما عندي، حتى اعرف اذا التربة بحاجة لاسقيها او لا. الرايت ايمج هون عم شوف المزروعات، يعني عم بتطلع على الحقل باللون الازرق، عم شوف المزروعات اللي لونهم ريد اند يلو. ريد اند يلو الاصفر والاحمر، هو معناتهم نباتات عطشانه لازم اسقيها. فاذا مثل ما عم تشوفوا باول صوره عم شوف وين عندي مزروعات، ثاني صوره عم شوف وين عندي مزروعات وين التربه رطبه وين التربه يابسه. بثالث صوره عم شوف اي نوع من النبات بده سقاي واي نوع منه بحاجه لينسقى. فاذا هنا نحن بنسميه فالس كالر. بينما انا لما اشوف الصوره الطبيعيه ما راح تطلع بهذا الشكل. طيب رح نوقف هون ونكمل بالسلايد الثاني بالفيديو الثاني مشان ما يطلع الفيديو طويل، لانه بالايمج ريزوليوشن كوانتايزيشن بدنا نحكي شوي مطولا عن هالبارت. رح نوقف هون بهيدي البارتس وبنكمل بجزء ثاني مشان ما يكون الفيديو كبير.